Hello everyone, welcome, good morning. Welcome to this talk about going passwordless with ASP.NET Core. Just before we begin, just a quick question to all of you. Who of you is currently using passkeys already? Good, yes, perfect, thank you. The reason why I ask is, do I want to stress how passkeys work in the browser and all of that, or do I want to stress that a little bit less? So it's good to see that everyone has been using them, so I can go a little bit quicker there. Talk about passwordless, so we will have to start with setting up the problem with passwords and talk about, okay, why are passwords bad? Passwords are bad for many reasons. For users, they are a struggle to work with. People have to remember their passwords very often as a consequence of having to remember their passwords. They use passwords that are not complex enough, or they reuse the same password over and over and over again, which means that if someone finds their password, they can log in on pretty much any website that is out there. And you will see, and probably if you look around in bigger companies that you might work for, you will actually see that people still, to date, use post-its with their passwords on there, which is mind-blowing. But also there, it is a sign that passwords have an issue, because people have to remember their password, and if remembering means writing it on a post-it note, that is problematic. All of these also lead to passwords being very interesting for any attacker, anyone wanting to do a phishing attack, because anyone might be interested in that password, and if it's indeed being reused elsewhere, it is interesting to know your password, because if I find your Microsoft password, I might be able to order stuff on Amazon with the same password as well, if you reuse the password there. For us developers, they also have a couple of problems. You need to store passwords. I hope everyone in this audience is aware that you don't want to store them in plain text, but still to date, sometimes you register on a website, you get an email containing your password in plain text. Yes, I'm aware that you can send that before actually hashing everything and then storing it in a database, but very often it's also a sign that it's just stored in the database first and then goes plain text into the email as well, and that's not a good thing. But we all know that we have to store them. There's also things that we have to take care of in the browser. There's JavaScript injection, there's other attack vectors to passwords and so on. So it's not easy to work with passwords as developers either. Not as users, but also not as developers. We solve this by giving some guidance to our friends and family. If they're non-techies, we typically say, okay, remember 5 different passwords and reuse those 5. So at least the blast radius of a password leaking somewhere is a little bit smaller, and it's easier for people to remember because they only have to remember 5 different ones and not for every single application or website that they use. For somewhat techies, or people that we know are capable of remembering more than 5 passwords there, typically we say, okay, use a password manager, use the one that is in your operating system, use 1Password, things like that. And we say, create a new credential for every single application or every single website that you use, so that if that password leaks, only that one is affected, and you can keep working with that. Great solution. Well, if we look at Have I Been Pwned, and this was a screenshot from July this year, there's 14, close to 15 billion passwords leaked in there, which is mind-blowing. That is more than there are people on this planet, which is crazy. So pretty much every password that you may be using, there's a big chance that it's out there somewhere and people can find it and reuse it. So we might have solved some of the user concerns with remembering only 5 or using password managers and so on, but apparently the fact that there's still a leak of this amount of credentials out there means that as developers, it's definitely not solved yet. And it's still interesting for people to figure out how they can get access to the password database. As developers, typically we come with new workarounds on top of other workarounds, and one of those workarounds is, and it's actually a good workaround as well, is multi-factor authentication, where we add things like text message codes or one-time passwords that are generated by our password manager, things like that, which is fantastic because they add an additional layer of authentication on top of your password. So even if your password leaks, someone would still require your password manager to generate a one-time password to be able to log in and actually use that credential. So that's a good thing, but it comes with a number of UX problems. First of all, it's yet another step, so you have to implement all of the UI and logic, and people have to remember, okay, I have to do 2 things to log in instead of 1. How many of you are storing their backup keys when you register a new 2FA credential anywhere? Okay, that's about half of the audience, which shows that it's actually problematic UX because you have to think about storing your backup keys, because if you lose them, you can no longer log in. The provider is typically not going to help you because it might be some way of gaining access to your account. So typically they're just going to say, no backup code, no account, sorry. So that's also problematic. Text messages as 2FA is very insecure. It's easy to get a new SIM card, register the same phone number and so on, get the code and just log in. So that's a problem. But also with those, there is actually a problem with deliverability. I live in Belgium, which is well connected. It's a small country. We have internet, we have cell phones, all of those things. But even there, my parents live in a more rural area. And if they get a text message with a code, it might take 15 minutes because their cell phone might connect intermittently because the network in that specific location is not ideal. So might mean that people who want to log in actually have to keep in mind for 15 minutes that they wanted to log into your application. And with everyone, including myself, having the memory or the attention span of a goldfish, that's also not a good thing. And also you need another application. You need some other application to generate those codes. And was I using Microsoft Authenticator, or am I using 1Password for this account? Or you have to keep in mind so many things. So did we solve passwords? Not really. What if we could get rid of passwords altogether? Get rid of all of the passwords. Would bring a couple of benefits. First of all, no more need to remember passwords. No more need to store passwords on the server. So you don't have to think about securing access to your database. Probably you still want to secure your database because obviously you don't want any other data to leak. But at least the blast radius of your password database being exposed somewhere is no longer super big if you don't have to store passwords because there's no data. And there's also no risk of passwords getting compromised in that scenario. So meet passwordless. We're all developers, so if we start thinking about, okay, how would we build a passwordless solution where we can just log in without requiring a password, where every credential would be unique, tied to a specific user and so on, how would you build that? Typically, you would come up with something using public key cryptography or signing, which we are also using when you visit an HTTPS-based URL, for example. The server there signs their, or encrypts the HTML output, for example, with a private key. You get the public key from the server, and as a client, your browser can basically check whether that payload is valid and you're actually working with that specific website. So if you revert that and you would use client-side certificates, you could already be passwordless because you can generate a private key that stays on your computer. You could send the public key to the server and then just say, okay, look, I'm going to sign something, server. Check with the public key if this matches the signature that you would expect with this key pair, and then if that works, you're logged in. And that's exactly what happens with passwordless and everything that is going there. So the client would store the private key, the server would store the public key, and logging in would simply become a story of signing some string with that private key on the client, and then the server validating that string with the public key. So how this works is the client would say, I'm Maarten, sign it with the private key, so there would be a signature in the ticket that you would send to the server, and then the server would use the public key to validate the ticket, and okay, this is valid, you're Maarten, you're logged in. That's a solution to this. If you start thinking about this, and I want to stress this, like build this a little bit up, because you'll see that actual passwordless is also using all of these techniques, so I want you to be aware of what's going on behind the scenes there. There's 3 actions involved here. First of all, there's generating the key pair. When you create a new account, you want to generate a private key that stays on your machine. You want to generate a public key that goes to the server. Basically, registration is the generation step here. You want to sign the message with the private key, happens client-side, and you want to verify the message on the server, that happens with the public key. This also solves breaches, because if all you communicate with the server at registration is, here's a public key, even if that public key is exposed somewhere and anyone wants to use it for whatever reason, they cannot generate the same signature because they don't have the private key in that case. So in here, if Have I Been Pwned would have passkeys or passwordless data and public keys and so on, nobody can do anything with them because they're just public keys and you cannot generate the same signature that you would have with the private key. Are we there yet? We are not, because there's still a couple of other issues to be solved in this story. First of all, phishing. If I have a client and I sign my I am Maarten credential there, and I send that to a phishing site called fake.com, fake.com can just take that ticket, go to the actual website and just say, here, authenticate me, and they're still authenticated. So yes, I cannot generate new keys, but if I fish somewhere in between, I might be able to fish out a credential in this case and use that on the target websites. A solution to that would be including the origin where the browser is navigating to in that ticket. So what's going to happen is that the client is going to sign I am Maarten with fake.com, because that's the URL that is open in the browser, generate a signature with that, send it to fake.com, because that's a site trying to phish my credential in this case, which is going to work. And that will be sent to example.com. Example.com will check with the public key whether the signature is valid, but it will also check the origin that is in that ticket. So if that contains fake.com, that server knows, okay, this ticket has been phished. I'm not going to let this in and then basically reject the credential and not let you log in. Are we there yet? We are not. There's still the issue of token replay, of credential replay. If I have this ticket with example.com, a valid one with a signature and so on, and I send that to example.com, great, I can log in because the server can verify with the public key. But if I would reuse that exact same ticket on another client, for example, that would all still work because it just has I'm Maarten, example.com, and a signature, and that would still be valid. So a solution to that would be to, as part of the login and registration flow, to first get a challenge from the server, where the server says, okay, for this login attempt, for example, I'm going to send you a string that you will have to include in the credential, also sign, and then I can check whether those things match. So that's going to happen. My credential is going to contain my username or whatever is going to be in there, the origin, the challenge, and then the signature, and then the server can validate that and make sure that the ticket is valid and I can log in. With another client that tries to replay with the exact same tickets, the server can check its internal database and check, okay, that challenge has already been logged in and has been used, so I'm going to reject this login so you prevent token replay in this case. Good solution? I think so, and apparently the internet thinks as well. So with public keys and signing and these three actions, we actually are solving a number of problems. First of all, breaches. If the public key leaks, no issue, because nobody can do anything with it apart from look at it and go like, yes, I hacked the database and I got a public key, but they cannot impersonate you or log in. It solves phishing because you have the origin in the message. So even if you would have an embedded iframe or whatever, the browser would still sign the ticket with the origin that is being used. So if it's a phishing website, that's not going to be the origin of the actual application that you're trying to use. And it solves replay because the server can send a challenge and you cannot use the same challenge over and over again to try and log in. Good solution, and the FIDO Alliance came up with U2F and hardware keys to basically implement this as an internet standard. So the FIDO Alliance is a bunch of big companies, governments and so on working together on getting rid of passwords, so I love them for that. And they built a number of standards and protocols to make all of this work in the browser and your operating system and so on. Many years ago, I forgot the exact date here, they came up with the idea of having a universal second factor, where using this exact same technique of public and private keys and signatures and origins and all of that would be implemented as a protocol on the client that you can use in your operating system, but also as something that you could validate on the server. They came up with the idea of, okay, let's put all of this logic in a hardware key, for example, one of those Yubikeys. Anyone have one of those or use them? Yeah, a couple of people. So that was invented, and the security keys would typically be hardware that would be used to do everything. On top of the concepts that we've seen already, it also added a couple of new concepts. First of all, the hardware key could provide attestation. So if I, as a company, would give all of my employees one of those Yubikeys, my applications could actually check whether all of those Yubikeys would be of a specific type or from a specific production batch or something like that, where you can actually even narrow down which Yubikeys can be used. So someone who purchases their own model, which is a different model or something, I could reject those from logging into my applications. There's also the concept of user presence. Those Yubikeys, you could just plug them in and log in and all of that would work. But typically with U2F, there would also be a user presence requirement where the user would have to press a physical button on the hardware key so that you could not have like a background process running to try and generate new keys for you to log in. You would actually have to interact with the key to prove that you really want to sign into something. Could be a fingerprint, could be just the press of a button, but that was something that is in there. Also, the concept of a signature counter. Every single time you do, you generate a signature, there would be a counter that is incremented by 1. The server would keep track of it, the hardware key would keep track of it, and if at some point the number no longer matches, something fishy happened and you can reject the credential, you can reject the login because maybe someone is using a different key or trying to impersonate you or something like that. So an additional security thing there. The downsides, well, the cool implementation of these things is that they are stateless, so they do not really store a lot of data on the key. And the reason for that was when this all came about, it was expensive to add a lot of memory that would be persistent, so they thought, okay, let's come up with a stateless solution here and implement all that. Quickly covering that, because it is important to know that how these keys work and what the difference is with what we'll see later in passkeys. Because of this limited storage in the hardware key, there was the idea that each of those hardware keys would have a symmetric root certificate embedded in the device. Symmetric means that you can encrypt and decrypt just with one certificate. And whenever you would register with a website or with a web application, you would send a credential ID plus the public key to be stored on the server. But the credential ID would actually also be the salt to generate or the seed to generate a new key later on. So what this means is that when the credential ID is stored on the server, public key is stored on the server. When I want to log in with the hardware ID, I will have to enter a username because the credential ID will have to be researched. Server sends the credential ID to me. The hardware key can, with that credential, generate a new key pair that is exactly the same as when it was on registration, and then send a signed message to the server there. So really cool concept, but it has some downsides. First of all, you need to retrieve the credential ID from the server. So UX-wise, you would still require something like a username or a user identifier, where the user would first have to enter, I'm Maarten, server checks, sends the credential ID, and so on. So in terms of UX, there's a couple of additional steps involved. And also, if the Yubikey is reset, you want to reset credentials there and say, okay, this account has been hacked or whatever, there's no option to reset just a single account. The only option is to reset that big symmetric key that generates the new keys going forward, which means if you reset that, you lose access to all of the applications that you have used that key with. So that's a couple of downsides there. Good news, standards evolve, and in comes web authentication. I'm going to say web authentication because I cannot say WebAuthn. I would not be able to do this for the entire talk. So web authentication, WebAuthn, same thing, or passkeys. Passkeys actually use all of those U2F properties to basically implement the login and everything that is in there, but they add a couple of additional things. First of all, they are stateful, which means that if I want to sign into example.com, my browser can already figure out, okay, which credential am I going to use because I know the origin and so on, so there's no longer this UX interaction required where the user says, okay, I'm Maarten, can you send me the credential ID? So UX is better, but it also means by being stateful that I can reset keys for a specific web application, for example. So if my Amazon.com account, for example, I no longer want to access it or I want to reset that credential, I remove the private key and none of the other credentials are affected. The nice thing about being stateful is also that all of these credentials can be synchronized across your devices. We'll cover that in a little bit. There's also additional options that were introduced. So for example, you can require in a passkey that the user verifies their login with biometric data or with a PIN or something like that. You can give UI hints where you can say, okay, use your Yubikey or use your Windows device or whatever. You can do something like that. And you can also require the passkey to be a platform or a cross-platform device. So you can still force the use of, for example, a hardware key there where you say, okay, it has to be something that is not synchronized through the cloud and so on, something that is just one device. And then there's the concept of authenticators. The authenticators is really what will do the authentication. It's the thing that will do the signature and the private keys and public keys generation and so on. Authenticators can be hardware, but can also be software. And that's the more interesting thing here with passkeys. All operating systems today implement the web authentication standard, which means that your operating system is going to be an authenticator. Password managers implement it, your cell phone operating system probably also implements it, and so on. So it's interesting to see that you no longer need this hardware key. You no longer have to think about, okay, where did I put my keys that contain my Yubikey and all of that. You can just use your phone or your computer and all of that. Being software also means that you can synchronize between multiple devices. So if I use my Apple machine here and I would have an iPhone, I would log in with my Apple account and my credentials would be synchronized across devices. So whenever I would sign in, I can just sign in with a passkey in that case. Also interesting is because they synchronize and because you can also synchronize on the fly, there's actually a cool thing where if I use a device that is not mine, but I still want to log into a particular web application, I can scan a QR code with my phone, do the login on my phone, and then the passkey will be sent through that channel, which is also a really nice addition compared to having the Yubikey and having to put it into a different device and all of those things. So let's give you a quick demo of how you would log in with a passkey. I'm just going to start my server here. Yes. I already created a new account that has passkey support. So if I want to log in, the UX that you can do with passkeys is that you can do auto-completion, where on the username field, for example, you can already say, okay, for this particular origin, you already have a passkey. I can simply click it, use my fingerprint, and I'm logged in. Let's log out again. On the login page, I can also do things like add a button where I can say, okay, log in with a passkey. If I do that, you'll see that I get a pop-up that asks, okay, which passkey do you want to use? In this case, it's also going to be the one that is stored in my browser. But imagine I'm on a different device. I have no passkey there. I want to use a different passkey. I can use my phone, grab my phone, just scan the QR code there. You'll see it tries to make a connection with my computer now. And I would be able to log in. I'm not sure if this is going to work because I don't think I'm using 1Password here still and disabled it on the Mac. Yeah, it's going to fail, but you get the idea. I can use a different device to do the login here. So it's pretty cool to see all of that in action. What else is there? Yeah, there's a couple of other things. When I log in with a passkey, you saw that I can use a different passkey on my phone and so on. But if I would still have one of those Yubikey hardware devices, they would also show up here and I can use those. What's also interesting is that with web authentication and passkeys, you can actually have different authenticators chained one after the other. So in this case, if I cancel the login with Chrome, I also disabled that, but typically you would also see my macOS password manager pop up and say, hey, I might be able to provide a passkey here as well. So you can have a chain of passkey providers to log in, and you can use any of those depending on where you want to store a specific credential. All right, back to slides. Cool, so web authentication or passkeys, the terms are used among each other. They have a client-side implementation that you require in the browser or in the application that you are building, and they have a server-side implementation. Client-side, they implement U2F, so the old protocol with the hardware keys and so on, but also FIDO2, the new protocol that is passkeys and so on. And there's a browser API that allows you to create credentials and get credentials. There's two additional methods that you can use, but typically you would use those to create a new credential on registration and get to log in with an existing credential that you have. Now, it is called web authentication, so you would expect it's only in the browser and all of that, but it's actually also possible to write a native iOS or Android or whatever app that also uses passkeys, because there's libraries from all of the operating system vendors as well, where you can implement web authentication basically in any application type that you might have. I'm not going to cover those, but remember, this is also possible. You can log in into a native application as well. Server-side, there's also a couple of requirements. First of all, you will need two endpoints, one for registering a key and one for using a key, where the endpoint would give the client a big blob of JSON saying, okay, client, these are the requirements that I have for passkeys you are going to create or send to me to sign in. Those requirements can contain the challenge that the server is expecting to be signed. They will also contain the cryptographic options. So as a server, you can say, for example, I only want to allow a specific algorithm or something like that. You can give that information to the client, and the passkey will only use that particular thing. And then also all of the options, like, for example, I require a PIN code or something like that. For login, for registration, you will also need 2 additional endpoints, and those are the ones where you basically process the JSON that is the passkey or contains the passkey, and you basically use to validate whatever is there. So a couple of endpoints. If you look at this in a flowchart, it would be something like this, where you have the client, you have the server, and you have the authenticator, which is going to be your operating system or the browser. The client pings the server and says, okay, give me all of the options. How do I create a passkey? Server is going to return the JSON to the client, so you can work with that. Client is then going to use this browser or operating system API to generate a new credential, send the credential to the server. My server is there, so to the server. Or the browser is going to create that credential, and we're then going to send it to the server to do the actual login. So fairly simple flow. I'm going to repeat this a couple of times because it's also important when you start implementing things that you implement this flow, of course. Now let's have a look at what this talk was originally about, ASP.NET Core and Passkeys. If you're building ASP.NET Core applications, there's a couple of options to implement passkey support. Of course, there is our wonderful open source community where there's 2 libraries that you can actually use to build web authentication supports and passkey supports. You'll find FIDO2.net and webauthentication.net. Webauthentication.net looks to me like the library that Microsoft inspired their .NET 10 passkey support on as well. So if you're currently using that one, you'll also find it easier to migrate, for example, to the native implementation in .NET. There's a commercial option as well from Rock Solid Knowledge. They implement all the bells and whistles of the standards, so depending on what you require, what are your security requirements, it could be nice to look at any one of those. But for this talk, I'll look at the .NET 10 implementation, so the .NET version that is coming in, I think, November. So let's look at passkey support. I actually created a project beforehand, so I'm going to switch to that one. It is a Blazor server application. Now, if you create a new solution with .NET 10 and you want to include passkey support, the only option to do that is to create a Blazor web application with .NET 10 with server render mode and individual authentication. That is the only way currently to get all of the template information out. So if you want to implement this in Razor pages or anything like that, currently you're on your own. Just giving you that. The Blazor application, let's maybe run it so we can navigate through it a little bit and look at a couple of considerations that you might also want to make in terms of UI and everything there. So this is a template. I will first have to register an account. Let's say martin@example.org. I'm going to use this email as my password as well. Interesting fact or interesting thing here, I have to register an account with a username and password in order to go passwordless with this template. Think about it. It's not great, but there's solutions to that as well. My password is not complex enough, so here comes the interesting dance of trying to generate a password that is complex enough. Oh, come on. Let's try something else. This is very, very typical. Anyway, let's register. Yes, that worked. I have to confirm my account, and then I can log in with my email address. I think this was the password that I used. Yes, I can log in. And once I do that, I can go into my account, go to Passkeys, add a new passkey. In the background, now this flow started. I contacted the server, got the options. I'm now using this generation of passkeys, so I'll use my Chrome profile to generate one. Fine, store it there. Use my biometrics. Passkey has been created. I can give it a name. This is Chrome. Done. Passkey is in there. If I now log out, I can use my passkey, again, provide biometrics, and then log in, and that works. Perfect. That's what you get in a template. Now, how does this work? Anyone using ASP.NET Identity currently? Okay, a couple of people. So you probably know that ASP.NET Identity is built on a database schema that Microsoft provides and all of that. If you want to migrate to passkeys or add it to your existing ASP.NET Identity implementation, there's one thing that you will have to do. Where you add ASP.NET Identity, add Identity Core in this case, you'll have to set the schema version to Identity Schema version 3. That is the only way to script a new entity framework migration to add the required tables to provide passkey support. Just giving you that. There's a couple of options that you can provide as well. So if on your builder you provide identity passkey options, you'll see that there's options that you can provide that give you authenticator timeout, for example, so you have to log in within 3 seconds, make it really exciting and fast for people to log in. Or you can say, okay, people are going to be slower, let's make this 2 minutes or whatever, so you can set those options. There's things like isAllowed or algorithm, which is a callback where you can implement something like, okay, I want to limit the algorithms used for passkeys to specific ones, so you can implement that. You can set the server domain, so the origin that the server will check for when you sign in. Validate origin, another callback to also validate maybe other origins and things like that. So a couple of options that you can give. I will say, typically, you'll not need those. So default implementation is going to be good enough. It's going to use the current server URL as the origin and work with that. But know that you can customize a couple of things there. What else is there? Yes. In my startup code, there's also this map additional identity endpoints extension method. If I go in there, you will typically find that there is the external login callback and the logout callback and so on. But with .NET 10, there's actually 2 new ones there. One is passkey creation options. This is that first call that the browser is going to call into to get all of the options to generate the passkey on registration. And what this one is going to do is basically get my current user, get the current username, make passkey creation options, and then return that as JSON that the browser can process with to generate a credential. Same thing on login. Passkey request options is there where the username is checked, where we make a passkey request options in this case, also return that as JSON, and then the browser can run with that. So all of that is there. Then on the login page, here we are. You will find that there is a component being used called passkey submit. And when you want to log in, for example, there's an operation there that says, okay, I want to request a passkey. We'll see in a second what this all means. And this will basically render that login with passkey button on the login page here. It looks for input.passkey as the field where it will store the passkey JSON that then the server can process when the post is done to the server. And you can style it a little bit, give it a text and things like that. Passkey submit is a component that by itself adds a button called __ passkey submit, adds the child content, all of the styling and so on, so you can put a text in there, for example. But it also registers another component called passkey submit. I know, confusing because it's the exact same name. But this one is actually a web component. Who is familiar with web components? Okay, one person. Web components is basically JavaScript codes, or it's a way to build user controls in the browser. Let's call it that. So you can create custom components like grids or inputs, or in this case, a passkey submit form that can have its own event handlers, properties, things like that. Basically, create your own HTML elements. That's the rough description of this. This passkey submit component is defined in the JavaScript file that comes with the passkey submit Razor component. And it's basically a component that is bound here, where we say, okay, I have custom HTML elements called passkey submit, and this is going to attach everything together, make sure that the credentials are being created, and so on. I'm not going to go into too much detail, but you'll see when I submit, and it is the passkey submit button that submits, it's going to obtain and submit the credential. That's the start of this thing. If I click the button, I'm going to start submitting the credential. What that thing does is it obtains the credential, which is code that basically for logging in, for example, or for registration, will first of all fetch those passkey creation options, so the first step in our flow to get the JSON information there. And then we'll call navigator.credentials.create with all of that JSON to generate a passkey that will be stored later on. Not going to go much deeper into this, but just so you know where the components are and where the moving parts are. Right, what else do we have? And that's pretty much it. Maybe one more thing to mention. If you want to support all of the password managers and so on, this client-side code actually is very optimistic in that the password manager is expected to implement everything that is required for passkeys to work. However, when you submit the credential to the server, there's this JSON.stringify call that is being done here. One password, for example, will throw an exception when this happens, and you cannot use one password with the default template for .NET 10 there. You can solve this. Microsoft Docs actually merged the pull request this morning with some sample code on how to do that, but basically it means you need to manually JSONify the credential that is being created there. All right. Server-side, when you log in, there's going to be some server-side code as well. When you log in, you will get the input model, and the input model is going to contain, where is it? A passkey. And the passkey is a model that contains the credential JSON, so the entire credential that the browser created, and potential errors if the browser has something to report saying, okay, this passkey didn't work or whatever. In the login then itself, you will find that when I log in, and it is a passkey sign-in, so there is credential JSON being sent to the server, I'm calling signinmanager.passkey sign-in, and that is basically doing all of the magic in terms of validating the credentials and all of that information. So yeah, that's pretty much it. I can go into more detail if you want. Find me after the talk, and we can look at this. This is actually hiding a lot of complexity, but if you want to implement this, this is a nice API to get started with everything. All right, back to the slides here. .NET 10 passkey support is part of ASP.NET Identity. It's only included in the Blazor web app templates, but it does mean, because it's part of Microsoft's or ASP.NET Core Identity, it does mean that you can add it to Razor pages or MVC or whatever you currently have if you're using ASP.NET Identity. The only thing you'll have to do is port a couple of things from the Blazor templates into Razor pages. The store itself is entity framework based, so you will have to set the schema version to version 3, generate a new EF migration, and then you will find that there's a new table called ASP.NET User Passkeys. I'm going to skip this one, but we can. Well, I'll quickly go over this one. The JSON that is returned from the server with the options of, okay, what do I expect for a passkey? What's the challenge that you have to sign and all of that? You might have noticed that there's nothing on this flowchart where I'm actually persisting that JSON server-side as well to validate it when I register or log in. If I challenge you with a particular challenge that you have to sign, the server will have to know what that challenge was in order to validate it later on, right? So that JSON, where is that stored? Well, you will find when you sign in and go into the code in ASP.NET Identity that, where is that thing? Yes, here it is. That Microsoft, oh, where is it? It's deeper. We have to go deeper. I'm going to skip this one. Anyway, you will find that a custom authentication schema is registered. So you know that you can have multiple authentication cookies with user information and so on. And basically what happens is an additional user profile is basically generated, stored in a cookie, and then the client is just going to send that cookie over, and the JSON is part of that cookie as well. Interesting approach, because I would have expected that it would be stored server-side or something, and so on, but it's actually quite interesting, because if someone wants to DDoS your server with requests for passkey creation options and challenges and so on, you might fill up a sessions table or session storage quite quickly by storing it in the authentication cookie, and if the client sends it back to the server, you're actually avoiding that issue, which is a nice implementation, I think. Also keep that in mind if you want to customize part of the sign-in process. Microsoft is doing a lot of the heavy lifting in terms of adding that cookie, removing that cookie, and so on. So based on where you want to customize, it might actually make sense to use that authentication scheme manually and get the data out before Microsoft does its thing and removes the cookie again. Yeah, so that's it. All right, I had another demo on going usernameless. I'm going to skip that one, but you will find that in the templates, there is everything is built around the fact that you already have a user profile and you still need a user profile in that case. If you want to build something where all you want is to have a passkey to log in, no longer require a username, things like that, that is possible. The only thing you have to do is that you will have to change a little bit of the logic and no longer depend on the user being in the database. A couple of considerations. I mentioned when I showed this Razor template that when you start working with the template, you still need to create a user with a username and a password. The UX requires you to do that, but passkeys do not require you to use that. So what you could do is when the passkey is first registered, you could customize the flow there a little bit and check the passkey information. If the passkey information of the JSON that you get that contains the credential contains the backed up flag, it means that the passkey is either backed up on a second device or synchronized through the operating system or something like that. So it is safe to assume at that point that the passkey is safeguarded, is going to be synchronized and so on. And based on that property, you can, for example, say, okay, user, you just added a passkey, I know you backed it up, do you want to remove your passwords? So you could change the UX there a little bit and work with that. And if you have that hint, you can call the user manager.remove passwords and basically remove the password in that case. So you can change that flow. You don't have to keep using usernames there. There's another standard next to passkeys and web authentication, and that is the well-known passkeys URLs. Tools like 1Password, for example, they have this thing where they scan your credentials, whether you're using passwords on different websites, things like that. They will also check all of the items that you have in your password manager. They will call the well-known passkeys endpoint there occasionally to check whether your application supports passkeys and what the URL is to enroll, create a new credential, or manage the credentials. So if you want to implement passkeys, I would definitely say look at this standard as well. It's a very simple standard because you just want to add a small snippet of JSON to your server. It's actually quite useful to instruct operating systems, browsers, password managers to check whether you have passkey support. And if you have, they might give the user a hint to say, hey, do you want to maybe switch to a passkey there? So that's a nice thing to add. One thing that I definitely want to cover is this relying party ID and origin. I mentioned this at the beginning, that when you sign the ticket that you're signing in with, you also have the relying party ID or the origin in there. The origin is actually quite important because it can make and break your passkey implementation. Passkeys, when you register them, they contain the origin forever. If you change the URL for your application, the passkey is no longer going to work. That is the premise of passkeys, that you cannot phish, you cannot reuse all of those things across websites. So that means if right now you are example.com and at some point you want to switch to example.org, passkeys are going to be invalid. You cannot do that. You will be stuck with that domain name forever for authentication. So think about it up front. The passkey creation and signing options include a relying party ID from the server. So the server will actually tell the client as well what is the relying party or the origin ID that I work under. Defaults to the current origin domain. So this was this options.server domain that you could specify in the options there. It defaults to the current origin domain, but you can override it in those options. So if you have authentication.example.com, for example, where you log in, but you want to set the server domain to example.com so that the client will store that, and you can still change to auth1, auth2, auth5.example.com later on. This is an approach to doing that. So you can set the origin there and say, okay, this is example.com and not login.example.com. The browser will verify the relying party ID against the current origin, but will also allow for subdomains. So if you set example.com, the browser is going to create and log in with passkeys for anything that is example.com. It's also going to allow passkeys for www.example.com in this case, if the relying party ID is still example.com, for example. It's not going to allow creating a passkey for example.com when the server communicates its origin is www.example.com. So by playing with the domains there and the relying party ID on the server, you can actually broaden or generally configure the domains where your passkeys are allowed, that the browser is going to support. It also uses the public TLD lists that the browsers all use. So things like co.uk, for example, they are known to be one TLD. So it's not that if you set the relying party ID to co.uk, that all of a sudden every website in the UK can use your application for passkey generation. The server will then also verify the signature against the origin that the browser is embedding in the credential. And on the server side, by default, the .NET 10 implementation will just look at the server domain that you configured. If it matches, great, you can log in. If not, passkey rejected. If you implement this validate origin callback in the options, you can actually add additional origins there. So you can check whether, if it's not cross-origin, you know that the things match and allow it. But you could also check for specific origins that you also want to allow in there. So that means if you want to use passkeys on subdomains, you can actually set the relying party ID to be more general. So if you want to use, I don't know, app1.example.com, app2.example.com, but have passkeys generated for example.com, you can do that by setting the server domain. However, this is also a bit of a danger zone. Because if you also host user content on example.com, anyone who can write HTML or JavaScript and host it on that domain that you also have there can generate and inspect passkeys that are created for that domain. So if you have something that has user-generated content or something similar like that, if you set the server domain to be more generic, be aware that you're potentially opening up to generating passkeys for not the right relying party that you might have. One way to go about that is, for example, implement that callback and say, okay, I want to validate the origin and I will allow the origin example.com, www.example.com, and login.example.com. And if it's user-generated content or storage.example.com or something like that, I'm not going to allow this on the server sides. That's good, that's going to work, but remember, even in this case, the client side still allows you to generate passkeys for that domain and so on, so you're not completely secured by doing this, only the server side in this case. It could allow unintended logins if someone can upload some JavaScript somewhere, and it also could allow using credentials, exfiltration, things like that. It is passkeys, so the good thing is they can only exfiltrate like the public key and all of that, but still it is opening up something that you might not want to open up. General recommendation here, I would probably say don't serve user content from the same domain, use a CDN on a different domain name or whatever, something like user content-example.com and not a subdomain of it would also solve this issue. One other thing could be to use a common authentication endpoint where you could use something like identity server, for example, and have all of the passkey operations go through login.example.com. And even if you are on app1.example.com, you would do the login on that domain, and that would be the only allowed origin for all the passkeys there. That's also an option. Passkeys on multiple domains. Also interesting. Imagine you operate internationally. Amazon is actually a great example. They have Amazon stores in .com, .dk, .be, .nl. All of those domains are there. And they all are separate versions of the application, but all of them use the same credentials. I can log into my Amazon.com account with my Belgian account as well, and vice versa. With passkeys, same thing. How does that work? If the relying party there is saying, I'm Amazon.com and I do not allow Amazon.be, for example, how would that work? There's yet another addition to the standards called related origin requests, where you can also serve another well-known endpoint where you can say, look, for passkeys that are generated for this domain, I will also allow these other origins. That could be different domain names. All of your domain names will have to serve this file up and give the information about which origins are supported, but that is an option to make passkeys work cross-domain if you have a couple of domains. Do be aware, this only works, so the spec describes that at least 5 origins should be supported by the authenticator, and most browsers will probably allow more than 5, but the spec says at least 5. So it could be that at some point someone uses a password manager that said, okay, the spec says 5, it's going to be 5, and that's it. So this is going to work if you have multiple origin domains, but this might also not work if you have many of them and the authenticator is a little bit too strict on the number that is allowed. It's also not flexible. All of those origins must stay around forever. If you drop a domain and let it expire and someone else picks it up, you know that they have access to those passkeys potentially, right? So ideally, all of those origins must stay there forever. So those domain names will have to be registered forever by your company, by yourself, and so on, to make sure that nobody can pick anything up. And also there, I would say a good recommendation would be to use a common authentication endpoint where all of the operations go through a login.example.com, for example, and you do not need things like related origin requests where you add all of those domains and expose yourself to those future potential risks. Right. So in summary, what we covered here was the problem with passwords. People have to remember them, people can lose them, they can reuse them, and those make them very interesting to people phishing and with bad intentions. Going passwordless is possible with public key cryptography and signing. We saw U2F was the first implementation of that with hardware keys and all of that. We saw FIDO 2 and web authentication and passkeys. We've covered how .NET 10 implements them, just looked at the project template and so on. Again, Blazor templates, but if you have existing installations, you can actually port it all over and it's just going to work. And we covered relying party IDs and origins, because I do believe you have to think about those before you deploy, because you might shoot yourself in the foot at a later point in time if you don't think about those. Recommended reading, if you have a QR code scanner, this is not going to log in, this is not going to phish you or whatever. There's actually a book by Adam Langley called A Tour of Web Authentication that dives into all of the considerations, a lot of the spec, a lot of the technical details and so on. I would almost call it, this is like the Bible of web authentication if you don't want to read the actual spec. Have a look at it, scan it, and go read it if you're interested in the topic. With that, thank you, and enjoy the rest of NDC. Cheers.